Hello, welcome back to Daily LeetCode Live, where I do daily LeetCode questions, raw and uncut. So let's get started. So today's question is a medium. It's called remove all occurrences of your substring. So let's see what it wants. So given two strings s and parts, so we have two strings, perform the following operation on s until all occurrences of the substring part are removed. So find the leftmost occurrence. So it says following operation. It hasn't mentioned how many times. Well, actually, it says until all occurrences of substring part are removed. So find the leftmost occurrence of the substring part and remove it from S. Return S after removing all occurrences of part. So this reminds me of like finding like the find function maybe. So like we just find, or like we just keep doing find, and then like we can just get rid of all of them at the end. Yeah. Oh, but then we do have one slight issue as well. So yeah. So the issue is like let's say we remove ABC here. Well, we will have A and BC here. So after we remove that, we still have to remove here, like this here. So let's see what we can do here. Yeah, I think let's look at the bounds first. Like definitely. So part xy, yeah. So yeah. So let me draw it out. Actually, I think that will be a bit more clearer. So let's say we have A, B, B, and the part we don't want is AB. Well, after we remove AB here, what do we have? We have AABB, right? That means we have more ABs. So we have to keep removing until, well, there's no more AB. Well, it is an empty string, so there are no more ABs. So my first thought for this question is definitely the fact that the bounds are pretty low. So we can do an n squared solution. The second thing I thought of is like sometimes after we see something, like after we see like the parts, right? Well, we still have to check what happens after we remove that. So so that means we are kind of like we are removing the parts, so we are kind of popping the latest things that we see. So well, that reminds me of a stack, and I think using a stack will actually just solve this problem. So let's say for this case, so the AAABBB case, well, every time, so let's say we have a stack. Every time at the top, if we see AB, like if we see the part, we want to remove that, right? So we just get rid of that. And we can guarantee that after we remove that, well, because none of these below have triggered the stack to, has triggered like the removal, we can guarantee that like these are stable. So it is until we add another character that we have to check whether we have to remove. So in this case, yes, we have to remove. So the algorithm would be we add like each character to the stack, and we check whether the top is equal to the parts. And if it is, we want to remove all of those characters. And well, because like the length of the string is only 1,000, we only have to ever remove 1,000 times. So that will be ON. But where n squared comes in is that potentially we have to keep checking the top, like the top n characters, where well n is the length of parts, we have to keep checking that to see if it is equal, right? So that's the thing that's gonna cost the most time actually, and like there are ways to optimize it or speed up. I think it's called the KMP algorithm, but well, we don't need to implement it here. And yeah, let's get started on coding. So let's get the length of the string, and let's get the part, the length of the part as well. And then let's initialize the stack. Then what do we have to do? Well, for C and S, we want to add each character in, right? Well, so we want to do stack append C. So no matter what happens, we want to add that in first. So, well, if the stack, well, if the length of the stack is smaller than the length of the part, well, yeah, actually, let's use the part length. If it is smaller, then it is impossible for the top, like for, it is impossible for the stack to include the string, like the part string at the top, right? So we can just continue from that point on. So otherwise, the stack has enough length, so we have to check the top now. So how do we want to do that? So we can just do for yeah, actually one nice things we can do is we can reverse part, because we want to check from the top all the way to the bottom. So let's have that defined up there as well. So part reversed. I think that's how you reverse a string, I think. So for yeah, for I'll just make it a terrible name for character 2 in reversed parts. Well, we want to check from the top, right? So maybe we need a counter as well. Let's think about what is the cleanest way to do this actually. Yeah, actually, let's just have a counter from the top. So index. We'll have a stack here. Like we'll have the length of the stack at the moment -1. So that would be the index of the latest element, like at the top of the stack. So what we want to check is we want to check so if the stack, like if the element in the stack, well, if it is equal to the character in part ref, well then we don't have to do anything because they're the same. It's only when we see something that's different, we want to set something to false, right? So we know that we don't have a match. So actually we also need a flag here. So is same. So we'll set it as true at the beginning, but whenever we see one difference, we just want to turn this into false, and then we just break out of it. So that's like a tiny optimization we can do. And now, if it is the same, well, we have to remove parts amount of characters from the stack, right? So we want to do for in range part length. Well, we just want to pop from the stack. So we want to pop part length amount of elements. So well, that will just pop the matching string that we have. And yeah, I think at the end the stack the stack is going to represent the final string we want. So well, we can just join all the characters back together, and that should be the answer. Let's see if I made any mistakes. Oh. Huh. Yeah, let's see where I got wrong then. So it seems like it is removing everything now. Right, let's see. So stack append C. So we're adding each character in. So that's correct. Index. So after it got past that, we have this here, and so for C2, so that's the second, like that's the character of part ref. Well, actually, let's think about how it could remove D from here, because well that's not possible, right? Well, yeah, let's just print out what we have for stack, and yeah, let's just print out each step. That would be the easiest way to debug. So print stack. We probably also want the index, but we can sort that out, I think. So let's see what the stack is doing for now. So it has DAAB. Right. We should do it up here. So because this here is going to ignore all the cases where the stack doesn't have enough length, right? So yeah, that's correct. That's going to get here, and then yeah, let's just do it on top actually. Let's just do it. Let's just do it here. So for here, it will be when we append C in, which it should remove this here. Yeah, and it did remove because it added B here later on. Well, this is the step where I think I see the problem. I forgot to decrement index here. And it is looking at the same character or something. Yeah, definitely have to think about this. So it is right now it adds A and then it adds B here. So right now AAB gets removed. That's rather strange. So another way we can do is we can check what happens. Like what is happening when we are seeing the, like when it's same is, well, the same. Like we can check that. Yeah. Yeah, so you can see that it is matching like all the different stuff. So that's very strange. So that means something here is wrong. And well, let's figure out what is wrong here. So can we print part ref? I think we cannot because it is an iterator. Can we? Yeah, we'll just turn it into a list. Surely that helps. Yeah. I see my mistake. So like for an iterator, after we have done this, after we have done this loop, uh, what happens is that let's get here. So let's say we have an iterator of the array ABC. Well, the iterator also has a pointer. So like originally it points at A, and then after we like do the for I in range n or something like that, for n in array, the iterator loops through and then it gets to the end. So there's like a end thing here, but then it doesn't go back the next time we do it. So yeah, that's definitely my mistake. I should have just done reversed parts here. Like that optimization wouldn't work. Yeah, and I think now it should work. Yeah, okay. See, nice. Well, I'll see you guys tomorrow. Bye.